Hi, my name is Shehroz Ahmed, and in this video I'm going to discuss a topic of Calculus 1, and the topic that we have is integrals. So by definition, integral is basically the area under the graph. So if we have to find out the area under the graph, we can take the integral of that graph. So let's suppose we have a graph like this. This graph is of f of x. We will take the integral of f of x with respect to x, and we will get the area under this graph. Now this graph is going from negative infinity to positive infinity. We do not know the starting point of this graph and the ending point of this graph. So such integrals are called the indefinite integrals. But if we have a graph, for example, if a graph is like this, the starting point of the graph is at A, the ending point of the graph is at B, and we have to work out the area under the graph. So that area under the graph can be represented as integral from A to B of f of x with respect to x. So this expression will give us the area under the graph from A to B. So this type of integral is called the definite integral, and this type of integral is called indefinite integrals. So the bottom line is, if we have to find out the area under the graph, we can take its integral. Now if we have a graph like this, let me just erase it. So let's suppose we have a graph like this. So the integral from this point A, B and C, so the integral from A to B will be positive, and the integral from B to C will be negative, because in the integration the integral takes the area that is above the x-axis as positive, and the area below the x-axis will be negative. So this is the phenomena that you have to keep in mind while doing the question for the integrals. Now what happens if we do not use the integrals in order to find out the area under the graph? Basically we have two methods in order to find out the area under the graph. One method is the Riemann sum method, and the other method is the trapezoid rule. So for example, we have a graph, and we want to find out the area under that graph. So this is the graph. We want to find out the area under the graph. So the first thing, and we cannot use the integrals, or let's discuss that we are not using the integrals. So in order to work out the area under the graph, what we do is we will just split the area under this graph into small rectangles. So like this, 1, 2, 3 and 4, and then we can approximate the area of each rectangle. But you can see over here, this rectangle is like this. So these will be the rectangles. So if we find out the area of all of these rectangles, then we cannot get the exact area. So we can approximate the area under the graph by just adding the areas of these rectangles, but we cannot get the exact area. That's why we use integrals. But if we have to just approximate the area, then we have two methods to approximate the area. The number one method is the method of Riemann sum method. Riemann sum. So in this method, what we do is we just draw the rectangles underneath the graph and then calculate the area and add all the areas, and we'll get the answer. So there are three types of Riemann sum. One is left sum, one is right sum, and the third one is the center sum. So this type of sum is called the left sum. In this one, we will get the area underneath the graph less than the actual area. So in this one, our area will be less than actual, and the other one is we'll split the rectangles into this way, like this. We'll split the rectangles like this and calculate the area. So in this case, the area that we will approximate will be greater than the actual. So this is the right Riemann sum. Now the third one is we take the center points of all the rectangles. So this is center point. Basically our graph passes through the center of all the rectangles. So for that purpose I will pass through a line over here. These are the centers. So for this one, this line will pass from here. For this one, the line will pass through here. From this one, the line will pass through here. So this is the best method, best approximation method in which our area will be approximately equal to the actual area. So these three are called the Riemann sum method, and we will do the questions related to that in the practice question that we're gonna do. Now the next thing is the trapezoid rule. So in the trapezoid rule, we just calculate the area under the graph by using the area of trapezium. So let me just erase it, then I'll show you how we can apply the trapezoid rule. Alright, so in the trapezoid rule, you can see over here, these are not rectangles. Let me just undo it. Okay, so you can see these four are the trapeziums. So these are the trapeziums. This is one trapezium, other trapezium, third trapezium, and this is the fourth trapezium if we are connected like this. So what we do is we'll just use the formula of the trapezium for each of these trapezium, and then we will add them. So this is the first trapezium, second, third, and fourth. Now the length from here to here will be called the height of the trapezium. This side and this side, these are the two parallel sides. So I'll call them as H1 and H2. So if we have to calculate the area of the first trapezium, we can use the formula area equals to height times the sum of parallel sides, that is H1 plus H2 whole divided by 2. So this is the area of one trapezium. We will apply this formula onto the second trapezium, third trapezium, and the fourth trapezium. We will just add them and we will get the area under the graph that will be close to the actual area, but it will not be accurate. We can just get the approximation from the trapezoid rule and from the Riemann sum, but we can only get the accurate area by using the formula for the integrals. Okay, now let's move on to the integrals. So what are the formulas that we can use to find out the integrals of different functions? So let's discuss them. And the first one is the reverse power rule. Alright, so reverse power rule. So let's suppose we have a function and that function is x to the power of n. We have to integrate this function. So this is the symbol for integration, and we'll write dx because we are integrating with respect to x. So whichever variable by which we are integrating, we have to write over here dx, dy, or whatever. Okay, so when we integrate it, it will be equal to x to the power of n plus 1 whole divided by n plus 1 plus c. Because it's an indefinite integral, so that's why we write c. If it's a definite integral, then we do not need to write c. So let's suppose if it is a definite integral, then it's like from a to b, then we will just put the limit. I'll just write it here, integral from a to b x to the power of n dx. So it would become n x to the power of n plus 1 whole divided by n plus 1, and the limit is from a to b. So what we do is, first of all we will put a into x, and then first of all we'll put b into x and then a. So it will be equal to b to the power of n plus 1 over n plus 1 minus sign, and then we'll put a to the power of n plus 1 whole divided by n plus 1. So this is how we can solve for the definite integrals. We can just apply the limits, and there will no constant in the definite integrals. Now the next one is how we can take the integral of the two functions when they are being added. So let me just erase it. Alright, so integral sign f of x plus g of x. So these are the two functions that are being added and we have to integrate them. So its integral will be equal to integral of the first function with respect to x plus the integral of the second function with respect to x. So this is how we can integrate them. And the integral of the integral of a function when it is being multiplied by a scalar number. So let's suppose there's a constant c with which the function is being multiplied and we have to integrate this function. I'll put an integral sign with respect to x. It will be equal to c. This constant will go outside the integral sign, then comes the integral sign, so c integral of f of x dx. Because it's an indefinite integral, so we will add the constants at the end. Okay, no, we will add the constants once we integrate this function. So this is the rule that we apply on the two integrals that are being added and that is being multiplied by a scalar number. The integral that are being multiplied, the rules are different for them. We have to solve them first and then we can integrate them. Okay, now let's see the integral of some common functions. Alright, so indefinite integrals of common functions. So let's suppose we have a function 1 over x. We have to integrate it with respect to x, so I'll put the integral sign, put dx. That will be equal to ln x, because it's an indefinite integral, so we'll add the constant. Similarly, the integration of sin x will be equal to negative cos x plus constant. Then the integration of cos x will be equal to sin x plus constant. Similarly, the integration of e to the power of x dx, it will be equal to e to the power of x plus constant. So this is how we can just take the indefinite integrals of some common functions. Okay, now we'll do some examples for the integral sign for the integrals, and let's see how it goes. Alright, so here we have a question. So in this one it says, let me just scroll it down a bit. Okay, so what kind of Riemann sum is described by the diagram? So we have to tell which kind of Riemann sum is described in the diagram. So as you can see, the graph is to the right of these boxes. So it means that the Riemann sum that has been described is the right Riemann sum. So I'll select right Riemann sum and check the answer, and that's correct. Now let's move on to the next one. Alright, so in this question it says, what is the correct description of the subdivision in this Riemann sum? So we can see over here there are 1, 2, 3, 4, 5, 6 uniform rectangles. Okay, so 5 uniform subdivisions, no. 5 non-uniform subdivisions, no. 6 uniform subdivisions, yes. As you can see, these divisions, these rectangles, they are of uniform width. So these divisions are uniform. So 1, 2, 3, 4, 5, 6. So it's option C. So let's check the answer, and that's correct. Now let's move to the next one. Alright, so in the next one it says, approximate the area between y equals to hx. Let me just scroll it down a bit. Y equals to hx and the x-axis from x equals to -2 to x equals to 4. Use the right Riemann sum. So in the right Riemann sum, we keep the graph to the right of the divisions. So the first division will be like this. This is the first division. The second division will be up till here. The third division will be up till here. The fourth division will be this much. In fact, I'll just make it over here up till here. And the fifth division will be up till, so for this one I'll make this as the division, and for this one I'll shift over here. So this is my last division. Now I'll calculate the area of all of these divisions and add them up. I'll get the total sum. So it's the area for this rectangle is 1, plus the area for this rectangle is 4 times 1, that is 4, plus the area of this rectangle is 3 times 6, that is 18. Area for this rectangle is 5. So 1 plus 4 plus 18 plus 5, that will be equal to 28. So for this one, 28 should be the answer. So let's click 28 and check, and it's correct. So this is how you can approximate the area under the graph by using the method of Freeman's sum. Now let's see some other questions. Alright, so this question is about the trapezoid rule. In this question it says choose the expression that uses 4 trapezoids to approximate the area under the function f of x equals to 2 ln x on the interval 2 to 8. Alright, so we have 4 trapezoids, and we know that the formula for the trapezoid is height times the sum of parallel sides, like I'll make it as a plus b. A and b are the parallel sides, divided by 2. So this is the formula for the area of the trapezium. Now let's calculate the area for this trapezium, then this one, then this one, and then this one. So the area for this trapezium will be, now this is 2, and over here we have 4, this is 6, this is 8. So over here we'll have 3.5, this is 4, this will be 5, this is 6, so this will become 6.5, and this is 8. So the height of this trapezoid is 3.5 minus 2, that is 1.5, times, and the sum of parallel side. So this side will be ln 2 plus this side will be ln 3.5 whole divided by 2, plus, now similarly the height of all the trapezoid is 1.5, so I'll take 1.5 as common, then I'll just add the sum of the parallel sides and divide by 2, divide everything by 2. So that 2 I'll take common over here, so the outside will become 3 by 4, and inside this side will come for once, this side will come for once, and this side, and this side will come twice. So it will become 3 over 4 times ln 2 plus 2 times ln 3.5 plus 2 times ln 5 plus 2 times ln 6.5 plus ln 8. So it should be this answer. Now let's check the correct one. So, well, unfortunately we do not have such option. So, well, let me check. Well, over here I have chosen option A, but I don't think that it's a correct one, but over here they are saying that this is the correct one, but in actual this is the answer. 3 over 4 times ln 2 plus 2 ln 3.5 plus 2 ln 5 plus 2 ln 6.5 plus ln 8. So this is our correct answer. Now let's move on to the next one. Alright, so this question is about the integration. Now we have been given a function and we have to integrate it. Here's the sign of integration, and we have to integrate this function with respect to t. So I'll take 14 outside the integral sign, and it will become 14 integral t of dt. That would be equal to 14 times t, like t 1 plus 1 divided by 1 plus 1, plus, because it's an indefinite integral, so I have to write the constant. So it will become 14 t square over 2. That will be equal to 7 t square plus constant. So 7 t square constant, this is the answer. So let's check it whether it's correct or not. So it's correct. So this is how we can use the power rule, inverse power rule, to work out the integral for such functions. So I'll try another. Alright, so here is another one. It says it's 4t to the power of 1 over 3, and we have to integrate it. So its integration will be like 4 integral sign t to the power of 1 over 3 dt. So it will be equal to 4 bracket t to the power of 1 over 3 plus 1 whole divided by 1 over 3 plus 1 plus constant. So it will become 4 times t to the power of, it will become 4 over 3 whole divided by 4 over 3 plus constant. So 4 divided by 4 over 3, that will become equal to 3. So it will be like 3 t to the power of 4 over 3 plus constant. So here's the answer, E part. So let's check mark it, and it is correct. So this is how we can use the Riemann sum, trapezoid rule, and the integration formula to work out the area under the curve. So I'll just stop up till here, and this is it for the integrals for calculus 1. I hope you got the understanding of these concepts and liked the video. So thank you so much for watching. Thank you so much. Bye bye.